Hi friends, in this class I would like to present a topic called emotion recognition using wireless signals. So what are the topics I'll be covering in this? I will have a small introduction and what is emotion recognition and what are the stages involved in it, what is the existing approaches we have, what is EQ radio architecture and what are the components of it, evaluation we got from this experiment, and what are the applications we have for the system, conclusion and the references. Let's get started. So I would like to start with the question, can we build machines that can sense our emotion? And the answer to this is yes. This paper demonstrates a new technology that can infer a person's emotion from RF signals reflected off his or her body. EQ radio transmits and RF signals and analyzes its reflection of a person's body to recognize his or her emotion states. A person can be happy, sad, excited, or angry, can be easily captured through the system. Emotion recognition is an emerging field that has attracted much interest for both the industry and the research community. It consists of two stages. The first one is extract the emotion related signals like audio visual cues and physiological signals, and then feed these signals into a classifier in order to recognize the emotion. So these are the two broad stages which is involved in the emotion recognition system. What are the existing system we have already? That is audiovisual techniques as well as the physiological techniques. Both the things has advantages as well as disadvantages. Let's go one by one. Audiovisual techniques rely on facial expressions, speech, and gestures. The advantage of this approach is that they do not require user to wear any sensor on their bodies, but can't measure inner feelings. For example, a person may be happy even if she's not smiling, or smiling even if she's not happy, but differ widely on how expressive they are in showing their inner emotions, so that varies person to person. On the other hand, the physiological technique is based on the ECG and EEG signals, and the results are very robust because they are controlled with ANS, that is automated nervous system, but it requires a physical contact with the person's body. On the other hand, the EQ radio system can capture the physiological signals without requiring the user to wear any sensor by relying purely on the wireless signals reflected off his or her body. So that helps us to not connect any sensor to the body, but even then we can find the emotion of a person. So EQ radio architecture consists of three components. They are FMCW radio, a beat extraction algorithm, and emotion classification subsystem. So let us discuss one by one. FMCW radio, which transmits RF signals and captures that reflections of a person's body. A beat extraction algorithm, which takes and captures the reflections as input and returns a series of signal segments that correspond to the person's individual heartbeats. An emotion classification subsystem, which computes emotion relevant features from the captured physiological signals, that is a person's breathing pattern and the heartbeat, and use these features to recognize a person's emotion state. So you can see here we have the RF reflection which we are capturing, and then we are dividing that into two types, that is we are getting the heartbeat segregation here, the respiration signals over here, then from here we are going to the IBI features, and then the respiration sickness is getting to the respiration feature, and these are combined together in the feature selection, and from here it is passed to the classifier, and in the classifier we will be able to classify the emotions, like whether the person is happy or sad or anger, using the classifier. So we will be discussing about this topics in detail in the coming slides. For example, for capturing the RF signals, the EQ radio uses a radio techniques called frequency modulator carrier waves. It focuses on time periods when a person is having which mode based on the formula which is used described in this slide. So we will be having the lambda as a wavelength, and dt is the travel distance between the device and the person, and t is a time variable. So other thing is the beat extraction algorithm. So the main challenge in extracting the beat intervals is the morphology of heartbeat in the reflected RF signal is unknown. EQ radio does not know how these beats look like in the reflected RF signals. To address these challenges, EQ radio first processes the RF signals to mitigate the inferences from the breathing. It then formulates and solves an optimization problem to recover the beat-to-beat intervals. The optimization formulation neither assumes nor rely on perfect separation of the respiration effect. So you can see over here we have the acceleration RF signals and the time frame in the bottom x-axis. So we are comparing that with the heartbeat which we are getting through the RF signals. So this is the heartbeat segregation algorithm used to segregate both the heartbeat as well as the breathing patterns which we are obtaining from the RF signals. So one of the nice feature about used in this feature is our algorithm can cover quickly both the random initialization as well as zero initialization, which is really helpful for providing optimum result and providing accurate result out of each object which are using in this experiment. As we have gathered all the RF signals, we'll be moving with the classification. After the EF radio recovers the individual heartbeats from the RF reflections, it uses the heartbeat sequence along with the breathing signals to recognize the person's emotion. So we will be having we have the various feature extraction and the classification, that is 2D emotion model, feature extraction, handling the dependencies, feature selection and classification. Let's discuss one by one. The model classifier is based on the 4 basic emotions, that is sadness, anger, pleasure and joy. So that is used as a main criteria to segregate and to find what emotion a person is having. The feature extraction, on the other hand, relies both on the heartbeat sequence as well as on the respiration signals. So EQ radio also employs respiration features to extract the irregularities of breathing. EQ radio first identifies each breathing cycle by peak detection after low pass filtering. On the other hand, with the handling dependencies, what happens is the physiological feature differ from one subject to another for the same emotion state, as I said before. So what happens is that can caused by the multiple factor, including the caffeine intake, sleeping patterns, and the baseline mood of a particular person. So EQ radio incorporates a baseline emotion state neutral to get an accurate result out of each object. The feature selection and the classification has a limited number of training data to improve the classification accuracy on the test data. So that was really helpful for finding the reducing the IBI error rate in the algorithm. Moving forward with what are the valuation they got through this experiment is they have conducted this experiment on more, I think, 30 objects, and during the experiment the subject is monitored both using EQ radio and a commercial ECG monitor. Further, a video is taken of the subject, then passed it to the Microsoft image-based emotion recognition system. The accuracy of the emotion classification is around 87% in EQ radio and 88.2 in the ECG based system. If one classifier is used for all the subject, the accuracy was around like 72.3% in EQ radio and 73.2 in the ECG based system. So pretty much they have a good amount of accuracy. And the algorithm which we had discussed earlier also has an error rate of 3.2 millisecond, which is less than 0.4 of the average beat's length. So here is a comparison of EQ radio system with the various other systems like image-based emotion recognition of Microsoft. So you can see over here in the x-axis we have the various emotions, and in the y-axis we are having the classification accuracy in percentage. So here you can see the green one is the person independent, and the orange color is the person dependent, and the blue color indicates the result coming out of the Microsoft image-based emotion recognition. So we can compare how accurate the system which we proposed in this paper. As we discussed about the system, we should also know what are the various applications we have from the system. So the various applications are, we can have a smartphone that can react to our modes and adjust the lighting, music accordingly. We can also have movie makers who would have better tools to evaluate the user experiences. The advertisers would learn customer reaction immediately. We can also detect the symptoms of depression, bipolar disorder, anxiety, etc. in a very efficient manner. And we can also have a machine which can interact with a person more like a person, a two real person discussing with each other. So the conclusion is this is really a good technology which is helpful for capturing the emotions through RF signals without connecting any devices to any person or any person's body, and just using the RF signals to capture the information. So this also builds a growing interest in the wireless system community in using the RF signals for sensing and expanding this work in various domains of emotion recognition. So this is the list of references which we used in this paper, and I would like to thank our professor for providing me a wonderful opportunity to present this paper. Thank you.